Okay, what's up, Algebra 1? All right, so we're jumping into a new unit here. So I'm gonna break this lesson up into two videos because it's gonna be a little bit longer. So let's just jump right into it, okay? Adding polynomials. That's what this first video is gonna be focusing on, adding polynomials. First of all, let's talk about what a polynomial is. All right, a polynomial is an algebraic expression that has more than one term, okay? So otherwise, if it's just one term, we call that a monomial, okay? But if we add a term to that, okay, now it's a binomial, and then you get a trinomial, okay? So you have, if that's all we had there, so let me get that negative 4x out of the frame. Pretend it's not even there, right? Pretend all we have is these three terms right here. So 7x squared, positive 8, and 2x cubed. If that's the only terms we had, you have one term here, 8 is another term, and then we have a separate term here, 2x cubed, right? And you're going to have a section in your lesson where you're just going to have to identify, what kind of polynomial is this? All right, so it should be pretty straightforward. Just remember that the terms of your polynomials are separated by addition or subtraction sign. So this is actually a 4-term polynomial right here, all right? All right, so, but the first step when you're going to add polynomials together is arrange all terms in descending powers of x. So we need to talk about descending powers of x first. All right, so I want you to notice this first example, okay? We're going to look at the variable that is first in the alphabet. So x obviously comes before y in the alphabet, so that's the variable that we're going to concern ourselves with here. And we want to rearrange this polynomial so that you have your highest power of x on the left, and then next highest power, and the next highest power, and the next highest power as you kind of work your way down. All right, so what that would look like, it would be, I'm going to rewrite this as negative x to the fourth y squared, because x to the fourth is my highest power of x, right? I have x to the third here, x to the fourth here, x to the first power here, and x to the second power here. So I'm going to write, and I'm writing the entire term that has that highest power of x. All right, so I'm not just writing just the power of x by itself. I'm writing the entire term that has or contains the highest power of x is going to go first. Then the next term is going to be the term that has the next highest power of x, which is this term right here, because it has an x cubed, or an x to the third power. So it's plus 7x cubed y cubed. And notice that I'm keeping this negative sign stayed with that term. This positive, there wasn't a positive sign, but since I'm writing it as the second term here, I need to add a positive here because it was positive right here. All right? Then this is going to be plus 2x squared y to the fourth. And then lastly, minus 3x y to the fifth. So it doesn't matter, the y terms don't matter right here. What the powers of y don't matter. We're talking about descending powers of x. If this was like 7a cubed b cubed, then we would be talking about descending powers of a. So we're just dealing with the variable that comes first in the alphabet. And notice it goes x to the fourth, x to the third, x to the second, x to the first, descending powers, okay? All right, now let's look at this one. We have 7x squared plus 8 plus 2x cubed minus 4x. So I want you to notice where this 8 goes, all right? So the highest power of x is 2x cubed, and then it's positive 7x squared, and then we've got minus 4x. And notice where this term right here that doesn't have a variable is going to tag on at the end, okay? So we have x to the third, x to the second, x to the first, and then any non-variable term comes at the end. Okay, so after you arrange the terms in the polynomials in descending powers, the next step is to add or subtract all of your like terms. You may say, well, hang on, what are you talking about subtract? I thought we were adding here, but hang on, let me show you an example. All right, so let's look at this example. So first of all, we want to put everything in descending powers, and we want the polynomials to be in alphabetical order, going from left to right. So I'm going to rewrite this. This is going to be 5x plus y minus 2. All right, so we want x and then y. And then any non-variable term is always going to come at the end. All right, now I'm going to line up. So we're adding these two polynomials together. So I'm going to line up all of my like terms. So it's going to be 5x minus 3y and then positive 2. Just remember to keep the signs. Remember, anytime there's a sign in front of a term, that sign goes with that term, right? So that shouldn't be read 3y. That's negative 3y. That's positive 5x. Okay. This is not 2. This is negative 2. Right. So now we want to look at this like we've got 3 columns. So we have 2 trinomials that we're adding together. Trinomial 1 and trinomial 2 here. Okay. All right. So now we're just adding. So 5x plus 5x is 10x. Y. Now we can look at this one of 2 ways. This is either y plus negative 3y, or we can just look at it y minus 3y. Well, that gives us, if it helps to add that coefficient right there, then that's 1 minus 3, so that's negative 2y. And then negative 2 plus 2 gives you 0, and it's basically just cancels out. So this would be our final answer. Okay, let's look at another one. All right, so we've got m plus n minus p, n plus p minus q, and p plus q minus r. All right, so what I want you to notice, I want you to pay attention how I arrange these. I'm going to write the first polynomial right there, okay? Now, when I write the second one underneath it to add it, I'm not going to put an n right here because you can't take m plus n. They're not like terms. I'm going to line up this positive n with this n. So n plus p minus q. Okay, so notice the q doesn't yet have a like term that it can be added with over here. All right, and then, so now I've got one more polynomial, which is a trinomial, to add here. And we're gonna put that, okay, so I'm gonna line up the p, so that's p right here, plus q minus r. So notice the r didn't have anything that it could line up with. All right, now let me draw my line here. Okay, so now we're just gonna add. All right, so there's nothing that I can add. If you can just imagine zeros here, wherever there's a space, you can just imagine a 0 there. So m plus 0 just gives me m. N plus n gives me 2n. Negative p plus p cancels out, gives you 0, and then 0 plus p gives you p. Negative q plus q gives you 0. Those cancel out. And then you're left with this 0 minus r is negative r. So this would be our answer right here. Okay, let's do one more example, and then I'll do a video on subtracting, okay? It may be helpful to rewrite this one like this, okay? So we've got, find the sum of negative 7a cubed b plus 4a squared b squared minus 2. Then so we've got polynomial here, polynomial here, polynomial here, and polynomial here. All right, so let's follow the steps. We need to arrange everything in descending powers of x, or I'm sorry, of a, in this case. So this one's already set up that way. This one's already set, negative 7a cubed b plus 4a squared b squared minus 2. That's already in descending powers of a. So I'm going to write that right here. So we've got negative 7a cubed b plus 4a squared b squared minus 2. All right. Now let's look at the second polynomial. All right. How should we rearrange this? Well, obviously it should be 3a squared b squared b squared plus 5. So I'm going to rearrange this as I line it up with the polynomial that's going to be added to. So I'm going to take my 3a squared b squared, I'm going to put it under here. So it's going to be plus 3a squared b squared. And then my positive 5 is just going to come right here and line up with its like term right here. Okay, see that? Okay, now let's deal with this one. This one's not in descending powers of a. It should be 4a cubed b minus 8a squared b squared plus 1. This term right here should be right here, and this 1 should be at the end. So let's rearrange it as we add it to our columns here, okay? So 4a cubed b, okay, that lines up with this column right here because we have a negative 7a cubed b. So I'm just going to line it up. That's a positive 4a cubed b, okay? Then we have negative a squared b squared. That's going to line up with this column. Negative 8a squared b squared. Okay? And then I have this positive 1. And it's going to line up right there. Okay? Then we just have one polynomial left. All right? Notice it's an a cubed b, and it's going to line up with these other a cubed b terms over here. So you could also look at it like this as 1 a cubed b. Okay? So we've got a positive 1 a cubed b. And then we have this half over here, 1/2. Okay, that's just going to come over here to our non-variable column. Okay, so now we're going to add these together. That's what it's calling for. It's saying find the sum of, which means we're adding, right? So remember, these are, if you look at these as 3 different columns. Okay, all right, so we've got negative 7a cubed b plus 4. So what's negative 7 plus 4? Well, that's negative 3, right? Negative 7 plus 4 is negative 3. Negative 3 plus 1 is negative 2. So it's going to be negative 2a cubed b. Okay, now let's come to the next column. 4 plus 3 is 7. 7 minus 8 is negative 1. So we can write it this way. This could be written negative 1a squared b squared. Or you could just write it negative a squared b squared. Okay, now last column. Negative 2 plus 5 gives you positive 3. Positive 3 plus 1 gives you positive 4. 4 plus 1/2 gives you 4.5. So this is 4.5. And this would be our final answer. Notice how it's in descending powers of a. Okay? So that's how we deal with when we're adding, okay? When we're adding. And again, you could look at this as 3a squared plus negative 8a squared, or if you just want to look at it as 3a squared minus 8a squared. Either way is fine, okay? Another video is coming up on subtracting polynomials.